We're all racing towards this future that's going to run on AI. But there's a huge problem. It's kind of like we're building the Tower of Babel all over again. If all these AIs can't talk to each other, it's destined for chaos. So today, we're going to dig into the one thing that can prevent all that, a set of invisible rules called protocols.
So let's really think about this. What's the central problem here? I mean, we're building a world just filled with AI agents, right? They're in our cars, our homes, our hospitals, everywhere. But what happens if they can't speak the same language, if there's no common ground? Well, you get miscommunication, and that's where the trouble starts.
And look, at first, these problems probably seem kind of small. Your smart thermostat doesn't get the message you left for the day. A self-driving car misinterprets a traffic light for just a split second, right? These are just simple, isolated signals. Getting missed. Annoying? Sure. But you might think, hey, it's manageable. But the thing is, these little misses don't just happen in a vacuum.
Because that one tiny missed signal, it doesn't just stop there. No, it triggers a chain reaction. That thermostat error, it contributes to a power grid imbalance. That car's little moment of confusion, it creates a traffic jam that, whoops, is now blocking an ambulance. All of a sudden, these small miscommunications are escalating into massive, system-wide failures.
And this, right here, is the ultimate cost. I mean, when our systems are unpredictable, when they fail without any warning just because they can't communicate reliably, our trust in them just evaporates. You simply can't build a future on a foundation of digital miscommunication. It won't work.
Okay, so how do we prevent this nightmare scenario? This brings us to the solution. It's all about creating a universal language of code, building that common ground for AI. And the hero of this story is a powerful concept called protocols. It's basically how we teach all these different machines to speak the same predictable language.
So what is a protocol, really? Well, you can think of it as a contract for machines. It's a shared rulebook that defines, well, everything, from the exact format of a message to what kind of response is required. It's the secret sauce that lets two totally different systems interact with absolutely zero ambiguity.
The best way to think about it is it's like learning a human language, right? You need grammar to structure your sentences, you need vocabulary for the words, and you need etiquette for a polite conversation. Protocols, they provide all three of those things for digital systems, making sure they can communicate clearly and effectively.
And when you get this right, oh man, the payoff is huge. First, you get interoperability. That means a system from Google can talk to one from Apple, no problem. You also get auditable interactions, a crystal clear digital trail of who said what to whom. And all of this is what makes these complex AI systems governable, scalable, and, maybe most important of all, safe.
Okay, so how do these protocols actually work in the real world? This is where we get into the layers of communication. See, it turns out communication isn't just one single rule. It's a whole set of rules built in layers on top of each other. This is called the protocol stack, and we're going to break it down for you from the ground up.
So, there are 4 main layers here. The best way to think of them is like building blocks. Each one handles a very specific job, and it relies on the layer right below it to function. Let's start at the very, very bottom, with the physical connection itself. All right, layer 1. This is all about the physical connection. Think Wi-Fi, the Ethernet cable plugged into your wall, or Bluetooth on your phone. This layer is all about the absolute fundamentals. How do two devices even know the other one exists, and how do they establish that first basic link? That's layer 1.
Okay, so once you're connected, you need a way to actually send information back and forth. That's layer 2, the transport layer. The backbone of the entire internet, TCP/IP, lives right here. Its job is basically to act like a global postal service. It takes your data, breaks it into little packets, puts an address on each one, and makes absolutely sure they all arrive reliably at their destination.
Now we're at layer 3, and this is all about the purpose of the conversation. So for example, HTTP, the language of the web, that's a simple request and response model. Your browser asks for a website, the server sends it back. Simple. But a different protocol, like MQTT, which is used a lot in smart home devices, it works totally differently. It lets a device, like a sensor, just broadcast its status to any other device that happens to be listening in.
And finally, we get to layer 4, which is all about meaning. This is where we define the structure of the data itself, using standards you might have heard of, like JSON or XML. This layer makes sure that when one system sends a piece of data labeled temperature, the system on the other end knows exactly what that number represents. This is the shared vocabulary that makes it all make sense.
But wait, it doesn't actually stop there. Wrapped around this entire stack, touching everything, are two absolutely crucial layers. First, there's security, to make sure the communication is private and trustworthy. And then there's governance. This is where big standards bodies like the ISO and the IEEE create the official rulebooks and run tests to make sure everyone is building their tech to the same compatible standard.
Okay, so this all sounds pretty straightforward, right? You just write some rules. Well, it's not quite that simple. This brings us to what we're calling the Great Balancing Act. It turns out that designing a protocol that actually works for everyone involves navigating some incredibly tricky trade-offs.
So, here's the first huge tension you run into: openness versus control. Think about it. Do you make the protocol completely open so that anyone can build on it and innovate, leading to really rapid progress? Or do you keep it tightly controlled to ensure safety and prevent people from misusing it? That is a fundamental dilemma.
And here's another one: simplicity versus expressivity. Do you keep the rules incredibly simple so it's super easy for everyone to adopt them? Or do you make them more complex and, well, expressive, so you can have more powerful and nuanced conversations between AIs? You really can't have both most of the time.
And believe me, the list of these tough choices just goes on and on. Do you prioritize constant innovation, or do you prioritize backward compatibility with all the older systems out there? Do you shoot for raw performance, or do you need to guarantee that the message's meaning is never ever lost? Formalism versus pragmatism, designing a perfect system on paper, or one that people will actually use? There are no easy answers here.
So, given all these challenges, how in the world do we move forward? This brings us to our final section, writing the rules for tomorrow. And the source material we're looking at today actually lays out a really clear 5-step blueprint for building a governable AI ecosystem.
All right, let's just walk through this blueprint really quick. Step 1, start with a minimal core protocol, but build in what they call hooks, so different policies can be added on later. Step 2, embed the data's origin, its provenance, right into the data itself. That way you always know where it came from. Step 3, create really robust tests to certify that a system actually follows the rules. Step 4, this is a big one. Security can't be an add-on, it has to be a mandatory part of the design from day one. And finally, step 5, governance can't just be a bunch of engineers in a room, it has to be a multi-stakeholder group with legal experts, civil society, the whole shebang. You know, this whole blueprint is guided by one core philosophy, which this quote just captures perfectly. It's all about a zero-based design. So instead of trying to patch old, creaky systems, you ask a very simple question: what are the absolute, most necessary building blocks we need? It's about intentionally leaving behind all that, that legacy baggage.
So, why does all of this matter? What's the end game? Well, the goal is to build a global system where compatibility is the default. It's the norm. A world where different technologies just work together seamlessly, instead of making compatibility some expensive afterthought that we're constantly trying to patch and fix.
And that brings us to our final and maybe most critical question. As AI becomes as fundamental as electricity or the internet, a global utility we all depend on, the rules that govern it become incredibly powerful. So the question is, who gets to write them? Who gets a seat at that table? That's the question we all need to be asking ourselves and asking our leaders.